Hello friends, wish you all a very happy and prosperous new year ahead. Today I am going to discuss about a material which is lightest of all. But don't take this material lightly because it has some very interesting properties. So friends, let's begin. The name of the material is Aerogel. If you weigh this piece of aerogel, it will be around 1.22 gram. That is only few times the mass of same volume of air. It is basically 99.8% air. In fact, some aerogels are so light that if you removed all air from them, they would be less dense than the air itself. So friends, let's understand why is aerogel invented, how it is prepared, why it is a good thermal insulator, and what are the usefulness of this fascinating material. So friends, let's talk about how the aerogel is being invented. Back in 1931, Professor Samuel Kessler had a bet with his colleague. Now the reason for the bet is jelly. Yes, you heard it right. Friends, jellies are basically a combination of solid and liquid. It is mostly liquid but embedded within this 3D solid structure. So the bet was this. Could you remove the liquid from the jelly without disturbing the solid structure? I mean, if you just evaporate the liquid out, then the solid structure will shrink because as you remove the liquid molecules, they pull on each other and they pull on the solid structure around them. So the solid structure would crumble. However, you are not allowed to affect the solid structure. So what you will do in that case? Samuel Kessler solved this problem using two ideas. First, he thought that the liquid inside the jelly can be replaced with another liquid just by washing it thoroughly. So you can exchange water with, say, alcohol. Now if you take the jelly and put it inside a high pressure vessel, which is also known as autoclave, then by heating it to a high temperature and high pressure point or critical point of the liquid will be converted into a semi-liquid semi-gas, which is also known as supercritical fluid. At this point, there is no boundary between a liquid and gas. Those molecules will no longer pulling on each other. So when you depressurize the vessel, that 1% mass of the gel left behind. The pores inside the solid skeleton where there was liquid now become gas. That solid skeleton or nanoporous solid is what we called aerogel. Kessler published his work in Nature journal in the year 1931. He made many aerogels using silica gel. The alcohol inside the silica gel is replaced with liquid carbon dioxide. Liquid carbon dioxide is non-flammable as well as it has lower critical temperature, which is pretty much advantageous. Once all the pores of the gels are filled with liquid CO2, it is time to take it to the supercritical point. This supercritical point is achieved by just heating it with a hairdryer. Here, now you are seeing supercritical carbon dioxide. In this state, carbon dioxide can be vented without affecting the solid structure, and what is left is called the aerogel. These aerogels are blue due to the same reason that the sky is blue. This is because all these nanoscale structures inside the aerogel scatter light, which is also known as Rayleigh scattering. The intensity of the scattered light is proportional to 1 over wavelength to the power of 4. This means it scatters short wavelength like blue much more than it scatters red. That's why aerogels looks opaque in ultraviolet and transparent in infrared. The low density solid is having several remarkable properties. Most notably its effectiveness as a thermal insulator, which is due to the presence of nanoscale pores. In fact, it is better insulator than the air. This is because the width of the pores inside the aerogel is smaller than the distance of the air molecules which they travel in average before collision. This distance is also called the mean free path. So that's why it is very difficult for hot air molecules to diffuse through these nanopores and conduct heat to the top surface of the aerogel. This is called the Knudsen effect. That's why these aerogels are used as thermal insulator in Spirit, Opportunity and Curiosity rover. The night time in Mars is very cold, so the protective layer of aerogel will save the electronics from this cold temperature of Mars. NASA will use this material as a thermal insulator in their future mission to Mars. NASA is also using this material for some interesting studies. Scientists are looking at the dust from comets to find out what the solar system was like when it was first formed. This mission is called Stardust mission. They want to know what the dust is made of and what shape it is. But it is hard to catch the fast moving dust. If the dust rubs against anything, friction makes the dust hot, which can change its properties. If the dust hits anything hard, that can also change its shape. So scientists are using aerogel in a dust collector on the Stardust spacecraft. As the very small dust particles go through the aerogel, they leave little paths. These paths are used to find the dust particle when the probe comes back to Earth. Aerogel is solid, but it can be less dense than air. The aerogel that was developed earlier by Kistler was very brittle and could not be shaped. Aerogels are traditionally expensive and difficult to manufacture, and they are difficult to handle. Now a team of scientists have discovered how to make it flexible so that it does not break so easily. This means there are a lot of ways in which it can be used to solve problems. Friends, there are many types of aerogel material. Silica aerogel is the most common type of aerogel and the most extensively studied and used material. It is a silica-based substance derived from silica gel. The world's lowest density solid is silica nanofoam, having density of 1 mg per cc. The density of air is 1.2 mg per cc. So you can see that this silica-based nanofoam is the less dense than the air itself. There is another type of aerogel material which is carbon-based aerogel, which is composed of particles with sizes in the nanometer ranges, covalently bonded together. They have very high porosity and surface areas ranging between 400 to 1000 meters square per gram. Due to their extremely high surface areas, carbon aerogels are used to create supercapacitors with values ranging up to thousands of farads. Carbon aerogels are also extremely black in the infrared spectrum, reflecting only 0.3% of radiation between 250 nanometer and 14.3 microns, making them efficient for solar energy collectors. The new class of polymer aerogels are up to 500 times stronger than their silica counterparts. A thick piece of polymer aerogel actually can support the weight of a car. Silica aerogel would crush to powder if placed under a car tire. As seen in this picture, the same is not true of the new polymer aerogel, which can easily support a car. These aerogels can be produced in form of thin film, which is so flexible that a wide variety of commercial and industrial uses are possible. These aerogels will come into picture in near future due to its very unique properties that I have described. Scientists are now trying hard to reduce the cost of this material so that it could be used to our day-to-day life. I hope that you have enjoyed this video. So in near future, should we make skyscrapers in Antarctica using these aerogels? What is your thought? Please comment down below. If you do like this video, then please subscribe to my channel. Thanks for watching this video till the end. We'll see you soon in my next video. Take care. Bye bye.